Hi guys, so I've just been getting the home workbench up and running again, and I think the basis of any home workbench really is a decent variable power supply. So it seems like a good opportunity to show you some of the power measurement functions of the new Tektronix MSO4 here. Today we're going to have a look at some input analysis, and we're going to have a look at the current harmonics on the input of this Omron power supply that I've got here. So I will show you what I've got rigged up, I'll show you how I've got it probed, and then we'll have a look at how to do the measurement on the scope. So this is the power supply here in question. This is a nominal 24 volt power supply, mains into the bottom, 24 volt DC coming out the top. We're then coming into this variable DC to DC converter here. Picked this up off of Amazon, and it just allows me to step down the voltage to whatever voltage I want to after this 24 volt section here. So to do a current input harmonics measurement, generally you want to probe the voltage of the AC line. So I've got a THDP 0 to 100 high voltage differential probe here. Typically you'd use something like this to take this measurement. So I've probed the live side and the neutral side of the AC line there, and also using this Tektronix current clamp here. This is a TCP 0030A, a 30 amp AC DC current probe up to 120 meg bandwidth on there, and that's just clamped around the line side of the input there. This DC to DC board, quite cheap off Amazon. We might do some more advanced measurements on that going forward, but for this video let's have a look at the scope. Okay, so now that we've probed the inputs there, we can see that we've got our voltage source here on channel 2, and our current waveform there on channel 1. So to take this measurement, let's come over here to the right hand side and click measure. This opens up the measurements menu. This is going to be a power measurement. And this is going to be input analysis of the harmonics, as we've said. So making sure our sources are set right, so voltage on channel 2 and current on channel 1, as we've said. So that's great. So clicking on a harmonics there and pressing add gives us the measurement. Cool. So already we're getting some measurements here, but we can configure that a little bit further. So double tapping on the measurement badge here on the right hand side, and we will first add a bar graph of the harmonics to give us a visual display, which is quite nice. Come down here and press configure. Here's where we can set things like our line frequency, so 50, 60 Hertz, 400 Hertz, or a custom value. We're going to test this particular power supply against an electrical standard. So we'll select the IEC 61000-3-2 standard, and we'll test against class A of that for this measurement here. So coming back to the top and pressing power auto set, sets the scope up in terms of record length and channel gains to make sure that we get an accurate measurement against that standard. So there we go, the scope's done its job, and we're getting some results there. So we can see that we're passing this standard for this particular measurement, which is great. But one more thing we'll do is add a results table of these, so we can get a nice tabular result format of the test against this standard. So we'll just stop the scope for a second, and if we come up here to the results table, harmonics results table, add, and here we go. Here's all our measured values, frequency, obviously which harmonic it is, what the limit of the standard is, and whether or not we've passed, and also a margin of error there. So really easy way to take current input harmonics measurements on this instrument.